Fire in the hole. All right, welcome back to Fro-Dog Arcade Repair. And in the Sanwa series, this is Sanwa number 3. Now, I started this particular chassis with the idea of showing a flyback mounting point repair, epoxying the ear back on, or the mounting stud, whatever you'd like to call it. And that went down a rabbit hole of this particular chassis. What I found first was that the flyback was not sitting flush on the board, the ear was busted off, the tab was bent a little bit here, and just overall things weren't sitting quite right. Well, I unsoldered the flyback and took it out and figured out why it wasn't sitting flushly on the board, and that is we have a cracked board. The board has taken some sort of blow, maybe in shipping or whatnot, and it's got a pretty severe crack this direction and this direction, both off the corner of that mounting tab for the heatsink and flyback cage. Now, if we look, this spot is just a little bit low. Let's see if I can get that better in frame. And this board corner is a little low. I'm not completely sure. I don't think the flyback cage is tweaked or overly tweaked, but what I'm going to do is we need to mechanically shore up this board and not have it under strain. Whoever did the repair work before, I don't like to dog or downtrod other techs. Everybody does things the best of their ability, and sometimes that's good, sometimes it's not so good, but oftentimes it's functional. I think this repair was probably perfectly functional. I just would like to see it a little more mechanically put together where the board isn't under the stress, the crack exposed like that. So I'm going to take off these trace repairs. I already tried to take that one off to get the flyback out. The trace repairs, and then I think I'm going to take part of this heat sink off and delve into how I can repair, glue epoxy, shore that board up, and then we can start putting it back together. Once we do that, let's take the rest of our visual inspection here. There's been a good bit of solder touch-up work. You can follow the flux from the previous tech. Didn't hit all the pins on that header. That one looks a little sketchy, but not terrible. It's usually the end pins I see on the other two Sanwas were a little more cracked. Let's see, Q804 is that one that I identified here that had ring joints on both of those other chassis. And let's see, those solder joints have been hit. What I can see is the pad moving. When that transistor didn't feel real tight, I can see that center pad moving a little bit when I touch that. So we'll probably pull that, what is the number again? Q403. And see if we need to do and or what we might need to do if there's a pad lift or how bad things are there. We'll test our horizontal output out of circuit. Actually, no, with the board turned this way. This is the power supply switching transistor over here, and horizontal outputs over here next to the flyback cage. In one of my earlier videos, I absolutely said that backwards. Catch that in editing. Got a resistor that's bent over pretty bad here. We'll straighten that up. What else do we see going on? It looks like it's had a couple of selective caps replaced, specifically this one. We still have glue on some of the others. It doesn't look like any of the other caps are replaced. While we, one of those down in there I think's been replaced. While we have the flyback out, we're going to take advantage of that space and probably go in and do caps if we don't see anything else egregiously going on with the chassis here. Let's see, we got a bent over pot. What are my chances of bending that back without breaking it? Pretty good. That one's a little bent as well. We'll need to touch those solder joints up, having flexed them like that. Rest of the pots look pretty good there. Excuse me. Now, one thing I do see, look at these yoke pins. Those yoke pins are all corroded and black. Now, one of them is reverse, one of them is normal. I think they both... Excuse me. Got the coughs there for a moment. I think both of those need burnished up and cleaned up. So I'm going to pull those out where I can work on them out on the bench. And let's poke around with the meter a little bit, see what we can find, if anything. My gut tells me this chassis is probably okay and will fire up. Might have screamed like a son of a gun based on the flyback and the looseness we had going on over here. It literally just was not flush against the board. It was raised up and kind of canted a little bit. And it didn't help that it didn't have the screw lug here, the ear on it attached to hold it in place. Don't know if the ear broke because of the board not being well, or if the ear got broke as part of when the board got cracked. I just don't know. But our flyback is absolutely a replacement. Made in China, just a little too clean. But we do have the ear back on it good and solid, and we'll have a fantastic mounting point. I did test fit it back down in there. Things line up well, and it does sit flush to the board better once we address some of that. So let's go to diode check, and let's take a look at, make sure what I'm looking at here. Let's take a look down at our horizontal output. Got a 1/2 volt drop that way, 1/2 volt that way, read shorted that way. But I do believe that's how it's supposed to read. What do we have on this trace potentially? That lead goes straight to 2 pins on the flyback, but with the flyback out, we don't have a winding in the way there. Let's go over to our power supply section. What's our main switching transformer or transistor looking like? 2 good drops. Nothing shorted. All right. Looking at the top side here, let's just see what our fuses look like. Are the fuses any good? That fuse is good. That fuse is different but good. It's not a ceramic. We should probably pop both of those out and check that they are the appropriate values. Now, another thing I'm seeing here, just like those pins on the yoke header, look at how tarnished and darkened and let's see, can I get that in frame just a little better? Look how dark and tarnished. And it's got black stuff flaking off of it. These fuse holder pins look... I think we've got a little more cleanup to do there. All right. Anything exploded? There is another cap that's been replaced right here by the vertical IC. Check on the face of the vertical IC, make sure nothing's exploded out of it. I think some straightening up, some double checking of... Alright, our last cutaway there, the battery went dead. What I was talking about was the fuse holder here. You can see that it's tarnished up. If I rub a screwdriver at it, you can see some of that tarnish coming off. And I went ahead and checked the fuses. Now, this one is spec'd here at a 4 amp, 250 volt. These Sanwas, all of them I've seen have had ceramic fuses. So I'm assuming that's for a reason, for heat or whatnot. This particular one had a glass fuse in over here at our 1.6 amp, 250 volt. Now, the glass fuse is a, what's the word I'm looking for? Not only it's a slow blow, but I'm looking at the design, and I think it's what they call a time delayed. But my biggest gripe with it is that it's 4 amps and we're only looking at a spec of 1.6. So someone's put the wrong size fuse in there as well. I went ahead and did, when we were doing our board checks, I checked to make sure the switching transistor and power supply wasn't shorted. I did a couple little checks on the sand block resistors that are flame-proof, heavier watt resistors. Make sure that we didn't have a couple of open ones. I don't see anything burnt or anything. I think perhaps they just didn't have the right fuse. Maybe wasn't making good contact, so they thought it was bad. I don't know. Either way, we're going to replace these fuse holders. They're pretty inexpensive and easy to get a hold of. I thought I dumped out 4, but I dumped out 5. So no big deal. We're going to replace those fuse holders, put the correct fuses in, and then we'll keep working around our chassis for the cleanup. And we still need to do our mechanical repair for our crack. Let's get these fuse holders out of here. I don't really know that I want to burnish them up as much as replace them. They're so darn cheap and easy at this point. I think I'd just as soon have new ones in there. Intermittent fuse holders are not where you want to be. Just ask 40-year-old Pac-Man cabinet linear power supplies about intermittent fuse holders that are kind of corroded or gummed up. That's a common failure point on those. Alright, let's heat that side, push it down, push it down. Wick that other fuse holder off if we can find it just from the bottom of the board here. Power supply is over here. Here it is. Sometimes you got to put your brain in reverse mirror mode, because you know what it looked like on the top. Now you got to find that same spot on the bottom for where your component's at. And that one dropped out pretty good. Okay, let's turn our board over and see what we got. There's those 4 pieces of fuse holder. Now look how the black crud is coming off on that one. Let's see if I can hold that a little closer to the camera. You see how the tarnish is kind of coming off of it there where I've mechanically scraped at it? I don't think I want to try to burnish those all up. We're just going to take those 4, put them in the deadwood pile there, and put new fuse holders on the board. Or I think we are. Those need spread just a little bit. There's a little better looking fit. Let's spread the next one. Now when you're putting these in, you might notice the old ones, yeah, the old one had tangs on them. There's a little tang right here. See that little tang? That is to keep your fuse from sliding out this way. So you gotta make sure you orient that tang to the outside so your fuse fits in the holder, snaps into place like it should. Okay, let's solder the new fuse holder in. I think a little piece of something stuck to my solder when I was grabbing the roll. I have to look on the floor, see what fell. Okay, now I think getting down to mechanically dealing with this crack in the board. Let's take part of this cage out. Let's unsolder the two lugs that hold it first. Nothing like a few more feet of solder wick. Let's see. So this lug and this lug. Okay, we left off. I realized that I ran out of memory in my phone and the video stopped. So where we left off, I believe, was we were going to desolder the primary lugs that hold part of this heatsink to the board. It's the actual cage around the flyback. And I've got some of the solder off, but what I'm working on right now is just removing these 4 screws that separate the 2 halves of the heatsink. It's like 2 heat sinks butted up against one another but screwed together for stability. And I've got one here that's way down in. Might have to use the really long Phillips to try to get a little leverage. There, I think we've got something moving. There it is. A really long Phillips gets us a little better angle as well. When I'm talking really long Phillips, this is what I'm talking about. It's probably 18. All right, so we've got our screws. Our 2 halves of the heatsink are now separated. We're free on that one for the solder, but it looks like there's still a little bit of solder on the other one. So we'll get the soldering iron rolling here and we'll try to clear that last little bit of solder off. Because this is the next day, iron's heating up at the moment. So while we're waiting on the iron to heat, it won't take but a moment here. We'll just keep looking for any other visual anomalies, anything else that might need touched up solder-wise. Yeah, we're up to snuff. Let's see what we can do about melting solder. in that short window of looking, I didn't see anything else. I think we're pretty good on solder connections on the board, visual anomalies. We just need to tidy up this corner that's cracked. See what we can do to get that fixed. No, there's still a little bit of solder bridging that on there. Now we might be free. I'm free! I'm free! No. Nope, still not. Double check that, yeah, that is on our piece we're trying to remove. Let's just try heating it. See what we get that way. Alright, let's do a little more wick action. Maybe we still have just a little burr hanging on. The trials and tribulations of getting big stuff to disconnect from boards. Oh, duh. We've still got the HOT attached. We don't take the screw out of the HOT, we're going to have to pull that son of a gun off the board the hard way. Then we'll have two cracks to deal with. Alright. This HOT does not have an insulator, it just has the case of the transistor straight over to the heatsink. Got some of our glue there on that coil that's holding us. We'll cut that, and ta-da! We've got that off. Let's cut this unneeded chunk of glue off. Oh yeah, we can see the divot in the border. You can really feel it with your finger. All right. We can flex it in the direction of the crack, but not so much in the direction the other way. That was the focal pivot point. That moved it a little bit. Let's find another device. How about this? This has got a nice nut driver's got a nice flat face on it. It's a balancing act of how much pressure can we put, not re-damage or further damage the board, but yet get it back into the shape we want. My guess is it's been held in that position for a while, and of course doesn't really want to go back for us. Visually that looks a little better. Feels a little better there. I wonder if some heat from a heat gun might help us. Let's go ahead and pull this C113, that cap that I couldn't find on Sanwa number 1 because it wasn't electrolytic. Let's pull that off the board. And clean up those pads. And then let's clean the glue off of the board here. On the Sanwa here, the glue is really just more like RTV than it is glue. I think it started white and probably just yellowed with time, age, and heat. Okay, that little spot's clean. All right, let's see what we can do on the edge of that board with a heat gun. So that we have some more pinpoint accuracy and control with our heat, I decided to use the hot gun or hot air rework that I normally use for surface mounts. Does about the same 575 degrees of heat as the true traditional heat gun, but it gives me a little more pinpoint accuracy. I think there's still a little bit of solder in our way right here. Make sure on all of these we clean that crack area good. So that we don't have any solder binding us up. Alright. Back to our heat gun. Yeah, let's just heat it good first. Oh, that crack falls right in there with that component too. Got a nice silicone pad underneath that helps with heat, so we're not burning and melting our bench. The old hot hand problem. We'll put our trusty needle nose in place, let them take the heat. Need to put the tip of the needle nose right at the edge of the crack so I can actually bend. I'm seeing little marks where the tip of the needle nose is touching, so we are definitely heating up that substrate. Left-handed, this gets a little tougher. How's that looking? Oh, that board definitely came a little more flexible with the heat. Let's heat this side a little bit. Put our gun up, see what we got. Ooh, that is warm. Definitely got a flatter board than we had before. Since the crack runs right up to the edge of that capacitor, let's go ahead and pull it as well. That C815. Okay, we'll lay it over there. And also have that resistor right there. Let's pull it too, because they're all right in that crack area and we're kind of right in the way. Okay, pad and component holes are opened up. Denatured alcohol. Let's clean this flux and the general board up on both sides where the crack is. And let's think about what we're going to use to help mechanically bond that crack back together. At minimum, the board's flattened out, so we should be able to get a nice seating on our flyback that isn't straining and messing up, but we also want some mechanical stability, and we want that crack to stop growing with any kind of movement, shipment, or whatnot. What do we have right there? We have another resistor, R130. There we go. Let's pull it out of circuit. And yes, I'm a little cavalier with pulling those because every one of those is cosmetically different. And I've got video evidence of where stuff belongs, as well as now that I'm on the third one of these boards, I'm starting to visually recognize what looks right, what doesn't look right. I really think CA is going to be our answer to kind of soak into that crack a little bit and stabilize it. The flyback itself should help hold things together. I don't know that I want to glom on epoxy at this point, because I think that's going to be a big goober of a show and a mess. And the board is pretty stable. It's just really bowed previously. All right. Let's get to some CA. If I can open it. The bottle's getting long in the tooth, almost empty, and not really a lot of oh, I know what I should use. Let me start with a different CA. That's like a medium viscous. Let's see, do I have any of the really thin stuff? Well, there's extra thick. Here's Super Fix. Let's see, what do we have? We have super thin, 1 to 3 seconds. I like that with the blue cap. Let's take some super thin. That way it should soak down in. And this is just the Instacure brand cyanacrylate super glue. I don't know if the tip's going to be clogged up too much for us or what we're going to do there, but we're going to find out. Here's a notepad. Oh yeah, right there, it comes right out. Okay. Okay, we got a nice line of super thin on there. That kind of soak in a little bit, but also mop up the extra. Oh, I flipped the Q-tip. I felt it touch my hand. Oh, not too bad. I don't think I'll be gluing myself together today. It's always a plus. Always a good day when you don't super glue yourself together. At least that's what James Wood said. Always a good day when somebody don't glue you together. Google it. It's funnier if you know the backstory. And yes, I do sometimes just amuse myself. If I find it funny, why doesn't the world find it funny, right? But I do have that Family Guy type humor. So enjoying an episode like me and James Woods would be funny. And what the internet rumor of what happened to old James Wood in a relationship with Sean Young. One of my Hollywood crushes from back in the day. Oh, yeah. We got a little bit of Sean Young in Blade Runner. Fantastic film. When I was a VCR tech, for whatever reason, the video cassette for Blade Runner was remarkably close in output and pattern to test tape that we used for alignment. And we had a shop that we had one alignment tape, or maybe it was two, but there was usually competition between the techs on who's going to get to use it, do their work, because there was not certified alignment tape for every tech. And I ended up finding that Blade Runner video did so well, and I think it was maybe not the movie all on its own. It was that particular cassette seemed to be close enough that I'd do the vast majority of my alignment work with it. Okay, I think you get the gist of what I'm doing there. Some super thin CA, letting it kind of soak down in the crack. We heated the board and I shaped it back out in the right way. The crack does not permeate the other side. Maybe there, the heat gun opened it up a little bit. I wasn't gonna spend a lot of time putting CA on this side of the board. Just didn't think it went anywhere. There's not a crack for it to go down into. Not a lot of use putting it in there. All right, I like that for now. We're going to let that CA cure naturally. Something else to prop the corner of the board there. Maybe just a little more in this area. It's so thin, kind of hard to get precise with it. Now, would it be so bad if it was sticking up on the board just a little bit? So we know we can scrape through it and get our connection. I think I might just do that. Might just leave it a little puddled in those spots and let it cure. I have a kid's birthday party to go to, so with the magic of editing, you'll never know the difference, except I just told you. And we'll come back to this, and I'll probably go ahead and get the flyback cage back in, reinstalled, everything resoldered. I think we understand the idea of laying a hard wire in and bridging that out. I'll take a meter and I'm going to test all of these traces out to make sure they go and make good connection where they're supposed to. And then we'll lay some of that green UV Cure Conformal Coating over the top of our trace work to seal that up, and that green ought to blend in, look halfway decent with the board. I think that's where we're going with it. When I come back again, I think we'll have finished product. All right, here we're back, fully reassembled. Got our flyback in, it's flush to the board. We've got our flyback mounting post, ear repair, a screw in that we didn't have. We replaced the insulator under the switching power supply transistor. I pulled the filter cap out, checked it, well within spec. It was like 650 mic and less than an ohm of VSR, and it's spec'd at 680. We had a little bald spot on the side of the cap here where it had rubbed through. I put a little bit of RTV. We had our fuse holders that were crusty and had some sort of tarnish on them. Replaced those on both fuses here. Now this fuse was the wrong value and wrong style. I robbed this fuse from another chassis. The fuse that was in there was this glass slow blow. What's the other term for it? I said it earlier in the video, but it is the wrong fuse because it's 4 amp and the correct fuse is 1.6 amp. So regardless of it working like a ceramic, probably not near the heat capabilities, but the fact that it was a completely wrong spec was the issue. Down in the cap cage, you'll see some of the Fro-Dog yellow there. While I had that cage apart and had the flyback out, I went ahead and changed the caps down in the hole because I fully anticipate to make this chassis work, and we'll do a cap kit on it as part of final maintenance. Checked the caps that came out, didn't have any issue there. Was happy with what I was pulling out. Did the neck board cap while I was at it so that the neck board was complete. I've cleaned all the flux on the neck board. We heated and flowed some CA down into the crack and restabilized this board. We put the flyback cage back in a position that was no longer putting the board on a bind. I did go ahead and put it back on its metal frame. You can see that here, just to make sure and support that board good as we go to put it on the tube to light it up. Now on the bottom side, I have not cleaned flux yet, and I have not done our conformal coating over here, our green UV curing coating to insulate those up. But we've got our bridge pieces in because our crack runs right through here. I don't know if you can still see it on the video or not, but it was flexed off of that corner. So we got the crack stabilized, we got the traces repaired. I went ahead and used the wire that the previous tech had for those traces. It was already nice and bent and a good gauge to take care of that. Reflowed any sketchy connections that I saw, the usual suspects like that Q403, and since I'm going to end up doing a full cap kit on this when I'm done, I have not cleaned the board yet. So next step, let's put it on a tube, light it up, and see if it works or it needs further troubleshooting. I also went ahead and wire tied the high voltage line in a loop like the factory has, so that that was already looped done and ready to go. We did some checks with our meter to make sure our HOT was good, make sure our switching transistor and power supply was good, checked the sand block resistor, checked the higher wattage flame proofs. Everything looked good. The bridge diode pack over here on the chassis is good. Cannot find any issues. Those couple of components I removed to gain access and fix the board, those two resistors and that C815 disc capacitor and the C113 disc capacitor back in. I'm feeling good about it. This flyback is a replacement and was new. I wonder if they replaced it because it was just, the old one just got physically busted when whatever happened to the board, or whether or not the board was cracked in some sort of shipping incident, or, you know, I hate to admit it, but when I was a younger tech, I forgot to take a screw out of a board, flipped the chassis up on a VCR and broke the corner clean off of it, and had to do trace repair and whatnot. And that was the first time I had to learn how to do that stuff. So, you know, accidents happen. Don't know how the board became cracked, but it definitely wasn't doing well because the crack had never been addressed and stabilized. The flyback was not firmly and seated well on the board. So we got that all tidied up. Let's go over the tube. All right, welcome back to Sanwa number 3, going on our tube. One thing that I didn't mention when I was going through all of the repair work that we've done thus far is the pins for the yoke connector, where we pulled them out, burnished them, and then I painted on a little deoxit contact cleaner and preserver, and then I worked that yoke connection on and off a couple of times to make sure I cleaned it up. So that was another little piece. We've got our remote board connected. We've got our signal cable. We've got our power cable that runs around clear back in here. We see our 2 power connections. We've got our decals coil connection made. We've got our CRT neck board attached and seated. Got our high voltage anode on. And we've got our ground connection to our CRT board. I think everything is plugged in, hooked up. Got our yoke connection. CRT board, both connections are plugged in. All right. I've got it hooked up to a little different test pattern generator, my old school BK Precision, because I was letting it burn in, letting another chassis burn in with that, just because it's AC powered and the batteries don't go dead on it, and I can just leave a color bar is the primary I use. So we're set to color bar there. Everything's plugged in, hooked up. I'd say time for fire in the hole. Just in case we get an explosion or any cool sparks or smoke, we'll move the camera over here. Fire in the hole. Oh, I hear we've got raster of some sort because I heard the high voltage come up. Let's go to the screen. Well, she don't necessarily look the best over there, but we haven't done anything to tweak stuff in. I'd say the screen voltage is up too high. Colors definitely don't look right, but things are up and working. It's taking some sort of signal. So I'm going to pause here, go get a tool, and we'll adjust it up a little bit, see if we can get something better out of it, or go back to the bench, troubleshoot colors. Alright, for a quick and dirty, I swapped the neck board with a known good, and that seems to have corrected some of our issue. Let's turn this to just raster. Let's turn our brightness all the way down. I'm going to bring our G2 up till we get raster lines. Just till they disappear. Now we can bring our brightness back up. Let's bring our color drives up. Oh, we got to go to color bars. All right, here we have our two neck boards on the bench. This, towards the back of the bench, top of the meter, however you want to look at it, this is the good and functioning neck board. This is the neck board that came with the chassis and is not functioning. This is the resistor I was talking about. It looks a little sketchy as far as like maybe it's gotten too hot. The color bands are burned off of it. Doesn't look like its brothers. Doesn't look like the other board. I'm going to start there. Just from a visual inspection, that seems like a highly probable. Let's get into, let's see what the one on the good board reads. 3.8K. All three should be about the same because it's 3 color channels. 3, 6, 7, 9, not too terrible. And 3.691. This one again was 3.8. All right, let's go over to this board. One that doesn't look crispy, 3.678. One that doesn't look crispy, 3.628. The one that does look crispy, 3.745. That isn't terrible. What about these other flame proofs? We've got some little ones here. 75 ohms, 73.3. Here's the third one. 74.5. Let's check the good board for comparison. 73.9. 73.3. 74. So those are 75 ohms. This resistor doesn't appear to be out of spec, just not the best looking. All right. Well, kind of goes in that territory of when you see something that's visually wrong, it's a good starting point. I'm not convinced that there's still not the problem lying with that resistor or something to do with it. Our color transistors are original and they're glued down to the board. Let's get on the bottom side of this board and look around. Let's go to diode. Let's just check our color transistors and see what they look like. Okay, here's the other one. That's probably in the board reversed, yep. Alright, let's go. Yep, checking the same as that one, and what do we got here? Our 3 color transistors check out. Is there anything wrong with the wiring? Do we have a loose or a bad wire? We do have a zip tie for strain relief, but our blue is good to the board, our white, our red, our green, our orange, our earth ground is good, our green, those all look fine. What else do we have going on here? Let's do a little better visual inspection. I had touched up some solder joints and already cleaned this with alcohol. I don't see anything. Wait a minute. This doesn't look right. Look at that. Let's see if I can bring that up close enough to the screen. What we're looking at is this pad right here. It's loose. Can you see it moving? All right. Let's go to continuity. Here's another point on the trace, and no continuity unless I push just right. We've got an open problem here. We got a busted trace on that. Oh yeah, I can see a little bit of the copper peeking on the edges here. Let's fix that. All right, now let's see if that repair is electrically solid with a meter. We should be able to go to ohms here and read our full value of about, what was it, 3.6, 3.7K. All right. I still find that resistor a little sketchy. Oh, pushed it clean through the board. Yeah. All right, I think in general that resistor is kind of sketchy. It's a little cooked. It's definitely been messed with on the board before. I think I'm going to check parts inventory and see if we have one. All right, so what it boils down to is I just didn't like the cut of that resistor's jib. So I went and borrowed one from another chassis since I do not have any 3.9Ks in stock. Went ahead and got it soldered back in, got the flux cleaned up off the board. Let's see if we have our connectivity, our continuity to that resistor. We do. And that's the only pin it touches is L902, which is a coil, which should read about 1 ohm. All right. Anything else going on in that circuit? Not this diode. That checks okay. All right. I think we had a busted pad there with that resistor. Now this one looks a little faded too, but at least you can see the color bands is not all chunked up. It looks fairly commensurate with the others. I think the next thing to do is put this neck board back on our chassis and light it back up, see what happens. All right, we're back over here with our now repaired neck board on. So, fire in the hole. All right, I heard our voltage come up. Our test pattern generator's on. And look at that. We got color bars. Fixed. I love it. All right, so we took a chassis that was completely unknown from eBay, had a crack in the board. We fixed the crack. We put the flyback in correctly. We tidied up a couple other things. We put our correct fuse in. We fixed a neckboard resistor broken pad. And now we have a functioning monitor. Thanks for watching. Thanks for tuning in for Sanwa number 3. And please subscribe to the channel. Hit that like button. And we'll see you for Sanwa number 4. I will do one more little segment on this with the cap kit complete, the conformal coating on, and show you the complete product that it's done. All right, welcome back. Here is Sanwa number 3. We have it on the tube and chassis. We've got our old school BK signal generator. We've got some good looking color bars. Been burning on the tube for a while. And we're all hooked up for our B plus adjustment. We're at 96 volts flat. And again, the B plus adjustments on these are to pull the 1.6 amp fuse. Well, I pull the 1.6 amp fuse, put my breaker across it because it is so tight in there that I can't really get gator clips on the fuse holder with the fuse in there. You can absolutely do it with the fuse in. You hook one lead to the fuse, hook the other lead to the M1 test point / test wire with the wire lead pulled out on the far end towards the back of the chassis, towards the back of the fuse holder, towards the main 4 amp fuse, that direction. You pull that end up, you hook a gator clip on there, you bring them over to your meter leads, and then parallel a light bulb across. Make sure your chassis is good and warm. Let it have burn in for at least a half an hour to be up to temp and up to operating specs completely in a nominally temperatured room. I think it's 60 something, so it's probably 70 in here in the shop right now. It's a little chilly outside, but that's our B plus adjustment. The adjustment itself is right down here. You just can't hardly see it tucked in there. See if I can get a pointer over to it. Right there. There's our B plus adjustment. So, Sanwa number 3. We had the cracked board on this one. We also, on the adjustment board, this was the one that had a replacement pot. And I also went to dial it in and found we have a broken pot. So, I have just the standard pot style, and the board is already pre-drilled for either size pot. So I was able to just put a standard 2K pot in for the horizontal position, and everything dialed in great. Let's take a look at some bars. Vertical linearity looks good. I tweaked that a little bit. The overall geometry, decent but not perfect, but yet I haven't seen a perfect one yet. Back to some color bars. Nice, good looking image. So, I think we're pretty well wrapped up with Sanwa number 3. I'll take a little final video of it on the bench because I've got to solder that M1 wire back in. And we'll call Sanwa number 3 a wrap. Thank you for watching the videos. Please subscribe and like. Would love to get you notifications of new videos as they come out. Once I get this initial Sanwa 7/8 series post, then I'm going to try to post at least something every week and keep chassis flowing. Thank you again for watching, and we'll see you over on the bench. All right, we're back looking at Sanwa number 3. Told you I would show you the final product after we got the UV curing coating on for insulating those exposed traces and bridge wires. So that cleaned up nice. And I wanted to show you the Amazon UV light that I purchased specifically for curing those UV insulation product. It's got a switch on it in line, and it is the correct wavelength for curing that, as well as at 50 watts it works way better. Well, actually 60 watts according to the back of it. Way better than the flashlight. Cures it faster. I would still say a good 15 minutes, but with the UV flashlight, I literally left it on overnight and found it cured in the morning because 10 and 15 minutes wasn't cutting it. But we have our completed Sanwa number 3. We know how to adjust the B plus now. Our board crack's all done up. This unit is complete, fully capped, fully functional, burn-in tested. Thank you for watching. Please hit the like and subscribe buttons and watch more videos on arcade monitor chassis repair. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.